If you took me on a tour of your R&D labs, what's the bleeding edge? What are the engineers at NVIDIA banging their head against and having pain, working nights and weekends, trying to get working? What is the bleeding edge internally at NVIDIA?
So we are working on many things. As I said, we have 3 computers, and we are trying to work on the bleeding edge of each of them. Right? If you think about AI training, we are exploring that the data that is going to come from physical AI is orders of magnitude more than what we had with LLMs. Right? It's the video, it's the audio, it's the touch, it's 24/7 being generated in the physical world. How are we going to absorb all of the data? How are we going to ingest that data and train AI models, right? So we are looking at, and that's why we're excited about Rubin and all the announcement that we had with Feynman. We need to keep pushing the envelope of computing to be able to do all this multimodal data ingestion and training and creating an AI brain. So that's happening on the training side. On the simulation side, we are really pushing the limits on how are we going to solve the data problem, right? We're building models like Cosmos and World Foundation models, which can, our latest paper was about what we call dreams, right? I don't know if you had a chance to look at that, where instead of actually going out and collecting the data, what if we could have a World Foundation model dream up the different scenarios, right? And also understand counterfactual, understand causality, understand spatial temporal relationships, so that we can accelerate the time for getting the access to data. You earlier talked about all these labs creating data and all these people creating data. Fundamentally, we will be limited by the number of hours in a day and the number of people that can do this, right? And we are really thinking, how can we make compute the answer to data? So that's a big area for us. Many approaches that inside the company, World Foundation models, neural simulators, and VLAs, and in addition to that, building highly accurate physics simulator, right? The work we are doing with Newton, so that you can have a ground truth that you can use to, when you're training your neural simulators, they also need to have a ground truth. So we are pushing the limits on that. And then the last piece is deployment. For large models and LLMs, they have the luxury of having entire data center at their disposal for inference, but a robot does not. It needs to run things real time on the device. It can go back to the cloud or the edge, local edge for some reasoning, but all the planning has to be done real time, instantaneously. It has to respond in closed loop. So we have built Thor, and we are really looking at ways that we can run today 10 billion, 15 billion, 70 billion parameter models onto the edge, because these robots are operating in the wild and they need to have that much intelligence.
Yeah.